Hi everyone, welcome to week 32 in the BinarX Student Payload Development Program. Today we are going to look at your Arduino micro-based prototypes that we saw at the end of last year at PDR Day at Curtin, or that you were very close to finishing, and most of you I think have finished by now. And we're going to modify this circuit design to fit onto the BinarX payload hat board, which look like this. And these are the ones that are actually going to go to space. So that's very exciting. You'll get the physical ones in a few weeks' time. And then there's no microcontroller board on this. It's just basically like a breadboard. But the microcontroller you'll be using is on these BinarX microcontroller boards. Again, we're not going to go into this today, but they're going to click together that. And once you've built your circuit and your payload, those two together go into our payload bay and go to space. So that's really exciting. So let's get started. So this is our Arduino micro pinout diagram. You remember from late last year, or maybe you don't, but that's why we're doing a refresher. This diagram shows all of the possible configurations that each pin can have on an Arduino microcontroller. Because if we look at the boards, there is a print or the silk screen on the boards. Hold that up. There we go. But beyond what's actually printed on the boards, there are more functions that each pin can have, and that is something you've been using designing your prototypes and something you'll need to understand to move over onto the BinarX payload hat boards. Let's zoom back in on pin A0 as printed on your physical Arduino Micro on your prototype, because the one we've been using lots and lots in our examples. And we're going to zoom in on the data sheet to see more of the details about all the functions that pin can have. So there's the zoom in. So pin A0 as printed on the actual board can also be an ADC channel. So by default, it's ADC channel 7. PF7 is the microcontroller port ID, which I don't think any of us have used. And then it can also be a digital pin in D18. And that's just when we're referencing it in our code. But we're not doing any coding today. Today is all hardware. So now it's time we take all that knowledge that you've developed on the Arduino micros and start to use it to design a payload circuit for the BinarX payload hat boards, which are, as I said, the ones you're going to send to space. So here we have the familiar temperature sensor circuit from week 19 of the BinarX program. We're going to use that as an example this week, but it's up to you and your team to have a go at working this out for your own sensors and components that are currently on your prototypes, and how you're going to connect those pins from your component to the BinarX hat board. So here's the top view. This is the side that you're going to solder onto, and then that's the back view, which just it has this way to space. So again, on this one, if we flipped it over, it's this way to space down here, down where my pointer is. But yeah, today we're not actually doing any breadboarding or any soldering. We're just going to draw them. The breadboarding and soldering will come in term 2, but we want you to have all of your design on paper and all your components ready by the end of this term. So looking at the pinout diagram for the Arduino Micro, see if you can work out which ones would go together when we compare it to this is a zoom in of the pin connections on the BinarX hat prototyping board, or payload board rather. So for example, the SCK here on our Arduino, just here, that might be familiar to some of you who've been looking at the cameras with the SPI or I2C, depending on which communication protocol you've been using. You have a look over at that and see where that sort of might relate over here. So you've got SPI, and so it's not exactly the same. You've got SCK, that's going to be CLK, so serial clock or clock. So as you can see, there's there's analog, there's pins that are similar to labels, and that's how we're going to start working out how we're going to move the physical circuit of our prototypes onto the new boards. So for those of you who've been working with analog sensors like photodiodes or thermopiles that are outputting to their analog signal to the AO pin on the Arduino Micro, can you remember what functionality of that pin, that AO pin that we were using, and then think of what connection that might move over to on the BinarX hat boards? Would it be one of the GPIO or general purpose in-out pins, or would it be one of our ADC or analog to digital converter pins? And regardless of which sensor type you're using, whether it's an analog or a digital sensor, we are going to need to consider power as well. So our power pin connections are over here. So have a look at the silk screen on the black and gold BinarX hat boards. We've actually grouped the pins together for you on the board. So you have a group of ADC pins, a group of pins relating to SPI communication, a pair of interrupt pins if you're using those, a group of GPIO or general purpose in-out pins, a group of pins relating to UART communication, a group of pins relating to I2C communication, and a group of pins relating to power. So they're grouped there really nicely for clarity. So to design your final payload circuit, you're going to need to go back to the data sheet for whatever component you're using. So as I said, we're going to use for the example, just so that you have something that's familiar to start understanding how you're going to move your own circuit over, but then you're going to do the work to move the circuit over yourself. We've got our little temperature sensor from our Bintro boxes and also from week 19. And I've opened up the data sheet here just because we want to remind ourselves what the pins do. So if we're looking from the bottom view with the flat side toward us, we've got the VDD or supply voltage, the V out, and the ground. So this is the temperature sensor MCP9701, but you want to have the data sheets for the components that you're using on hand, so you can remind yourself what all the pins mean. Double check the voltage requirements, current limits, etc., so you don't fry any of the components that you've already got. So from the temperature sensor data sheet, we see the typical circuit here, which is what we used when we built it on our breadboard with our Arduino in Tinkercad. And just a reminder of the power rails. So we've used power rails up here. You'll see some similar things on the hat boards when we get to that. All right, so let's have a close-up look at our Arduino prototype. I've made the labels bigger because you can't really see them in the image. We have ground, we have 5 volt, and we have connected the output pin of the temperature sensor to pin A0 on the Arduino. So in this example, remember we were using the power rails like we did to connect batteries, and so the 5 volt voltage in is coming via the Arduino Micro, and then we've connected it to the same ground because in this instance, this temperature sensor is being powered by the Arduino connected to the computer. So that's why we've done it that way. So if we have a look over here, this is a close-up of the BinarX hat board of all the connections. We can see we have ADC pins. So we can pick one of those for our temperature sensor output, because remember, that's what we did last year when we set up the temperature sensor on our Arduino circuit last year. We took one of the analog output from the temperature sensor and fed it to the Arduino's ADC or analog to digital converter on pin A0, and that gave us a digital reading based on the resolution of Arduino's ADC, which was between 0 and 1023, so 2 to the power of 10 or 1024 different values that it could have had depending on the reading. The ones we're sending to space have a higher resolution, which means we can get finer detail, but we're going to leave that for another day. So let's pick ADC 1 for the output pin of our temperature sensor, and we'll just draw a line, not a very pretty line. We'll draw that over and we'll connect it to ADC 1 on the on the BinarX hat board. All right, and then we just need to connect ground to ground. So we'll go over here, and this isn't very pretty. I'll connect, maybe I'll come over here. I'll come over here. I'm not going to worry about the connection to the micro. I'm just going to do it directly to the sensor. Pardon the mess. I'm going to go ground. Oh, and over here in ground, it's not very easy to see the black. I apologize. And then we're going to need to connect a supply voltage. So we had 5 volt on our prototype circuit, but we look over here in our power group, and we have 3V3, we have ground, and we have BAT. None of those, I don't think, don't look like 5 volt. So 3V3 is 3.3 volts supply voltage, ground is still ground, and BAT actually connects is a 9 volt supply. So you generally won't want to use that. That's the direct battery connection to the Binar CubeSat batteries, but we'll talk more about that later. But let's see, okay, so we don't have 5 volt, but what we can do, and you can do this for your own sensors if you're struggling, go back to the data sheet and have a look. And in the case of the temperature sensor, remember we've got this bottom one here, MCP9701, if we're going back to the example from week 19. The supply voltage for it is between 3.1 to 5.5 volts. Okay, so that means it will be happy if we feed it 3.3 volts, as long as we don't exceed the maximum. Oh, that's our low operating current. That's fine. All right, so We'll grab our red supply voltage and like this, and we'll connect it to here. But we want to actually design our circuit for what it's going to look like when we start soldering it. So let's. Okay, so back to how we would move our basic temperature sensor circuit from our Arduino-based prototype onto the BinarX hat prototyping board. You should have a PDF version of this drawing here from your teacher for this week. And it's basically a wireframe or just a really basic diagram with no details so that we can draw on it and make it really clear of this board here, of the BinarX. Sorry, flip it over that way. That way. So that is the board that we're going to be soldering onto, but today we're just going to draw our circuit on it. So you can either print it out and draw on it by hand, which is what I've done here, just plan. Or you can do it on your computer and just draw on it with Paint or whatever you want to use, as in Microsoft Paint or Photoshop or whatever you like. So we draw something like this on the board, and forgive my freehand drawing abilities here. So I'm going to draw the temperature sensor, and just to make it a little bit easier for myself to remember which way is which, I'm going to say, okay, well, that's the bottom of it. So that's the bottom view, like on the data sheet. And you can number the pins. I won't do it right now because it'll just torture you with me trying to draw. But it's got the 3 pins on it, so we're just going to connect 1, 2, remember on different nodes, right? Because if you look, and it's much easier to see than actually it is to do when you're on the breadboards, because you can see the copper tracers where things are connected. Anywhere that's connected, like by a continuous line of copper or just by an outline, those are electrically connected. So like on our breadboards, if we're using something like a temperature sensor, we have to go across different nodes that we've done here. So don't go this way. But like on the breadboard, we do have ones running along here that you can use for power rails and to move the circuit flow around a little bit and keep your circuit nice and neat. So the first thing I'm going to connect is the voltage. So we're going to go just like we did in an earlier example, but I'm going to use the power rails in this case. So in the middle here, I can use these. So then I can say, okay, we're going to travel up, 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 and I want to go into 3v3, so I'm going to come from this one. That would be my solder point there, and then I would come across here and I would solder to one of the 3v3 connections there. All right, and then the next one I want to do is the ground. So there again, I'm going to just bring the ground one which one's my ground pin? It's this one. So we're going to do our little solder point here and actually come over again to the power rail, the bit that I haven't used yet. And we're going to go here and solder it there. And then that means it travels all the way up here and I can just go like, oh, sorry, that was horrible drawing. Like this into the ground. Just like that. All right, so that's where that's going to go. And then I want to actually just notice, sorry, we should be soldering there. And there, you don't want to solder in the same dimensions. That is great. So these would be wires. These little lines that I'm drawing are representing wires that you're going to use to connect stuff around. And with the output pin, I'm going to come right from here. And I said I was going to do ADC1. It's a little bit messy, but I'm going to come over and I'm going to do this, solder wire in there. Now I could do a couple of things because I'm not doing, I could just connect the wire directly from here over to ADC1, but I'm going to be a little bit neater, and only because I know I'm not going to put anything else on this circuit, I'm going to actually use one of these long ones just to be like, okay, well, I'll come over here and then I'll go on to this first one, which isn't connected to anything else. And then I don't need to have a wire running all the way across my board, but this is connected so that I can come right up under where the ADC is. I'm going to go like that. So that's my basic temperature sensor payload for space. Now, the team at the Binar Space Program have actually been designing the final apertures or windows for the next Binar CubeSat missions. So we need any teams who need their sensors to see out of the CubeSat. So photodiodes, thermopiles, cameras, to be grouped in this area here of the payload board. So your wires can go anywhere like this. Your wires can go there. Your resistors, your capacitors, whatever needs to go, and then connect up to here. But we want your sensors to be down here and to face down that way. Remember, this way to space, if you flip the boards over when you get them, it's got the arrow showing which way is going to be out, looking out into space. So please, please do that. If you're using something that doesn't need to see out into space, like a magnetometer or an IMU, those can just go elsewhere on the hat board. And yes, as I've done in this example, please use, color code your wires and where the connections are. It will make us easier for us to help you check it and for you to remember what you've done. The drawing of this design for your own circuits is what you need to have done by critical design review at the end of this term. You'll also need to make sure that you have all the physical parts you need to build your final payload in term 2. I haven't gotten any emails from any teams last week about parts missing, so that tells me you've got all the parts you need for your final payload. I do know there's 1 or 2 teams that we've got components that we're bringing in. We've spoken to your teachers about that. But if that's not the case and you are missing things or you need extra bits, please email me on binarx@curtin.edu.au and let me know if you need anything else. Okay, so that's it for this week. You see there week 33 is actually more of the same. So this week's session is week 32 and 33, the circuit design of your space-ready payloads on the BinarX hat board. So keep working next week on that, and then I'll see you all again in week 34, where we're going to go over a tutorial to set up the STM32Cube IDE. So remember, we've been using Arduino IDE, or Integrated Development Environment, up till now. We're going to start looking at setting up the STM32Cube IDE. So as I asked in week 31, please make sure that you've all got that software installed on your computers or in your lab computers. Teachers, if you need some help with this, let me know. If you're not finding the correct software, but that's all in week 31, and creating your MyST account. But until then, if you have any questions or need any help, we're still coming out to do weekly visits, and you can always email us on binarx@curtin.edu.au. Thanks, everyone. Have a great day.